So this is problem set 4.1, and what we'll do here is just take some of these problems further into the problem set and answer them, starting with about 55. It's starting to talk about which numbers are larger than other numbers. So let's look at 57. So we have 0.02, 0.05, 0.025, 0.052, 0.005, and 0.002. All right, so when you're trying to decide which number is the smallest, one of the things I do is I put all of the numbers on equal footing, meaning this has 3 digits, 3 digits, 3 digits, 3 digits. These only have 2 digits, so I'm going to give them 3. So I'm going to put a 0 there and a 0 there. So now all of my numbers have 3 digits. Now I just look and see which numbers are biggest or smallest. So this number right here is 2, that's 5. 52, 25, that's 50, and that's 20. So notice when I named these numbers, I just said my first number here, and I looked at what was passed. This is a 20, so you ignore the 0. This, I go to the first number, I ignore my zeros, and that's just a 5. There's nothing following it. And I ignore the zeros, and I got a 52. So then I've got everything there, so it's real easy for me then to determine what's the smallest. So this one is the smallest because that's 2. That's 5. Well, I shouldn't have written 5. I should have written, that's the second to the smallest. So 5, and then what do I have? 5. Okay, this one here goes from 5 to 20, and then 25, and then 50, and then 52. And there's the order from smallest to largest. Largest to smallest would be the exact same thing, only we would put them in order from the biggest one to the smallest one. So taking a number such as 61 to 68, where they give you a decimal and they ask you to change it to a fraction and then reduce it. So what we do for like 62, it's 0.75. What we do again is we look at the number to the right of the decimal, and we look at the last number, in this case the 5, and the 5 is in the 100ths place. This is in the tenths place, and the 5 is in the 100ths place. So it's asking us to change this decimal to a fraction. Well, since the last number to the right is in the 100ths place, we put it over 100 and we just write 75 and put it on top. The hardest thing about this is then reducing that, because a lot of these decimals, most of these decimals, are reducible. So that whenever you hear the word reduce, you do the whole factor tree. So, and 75 reduces to 3 and 25. 3 is prime. 5 and 5, both of those are prime. So 75, the prime factors are 3 times 5 times 5. And let's do 100. 100, 10 and 10. And 10 reduces to 2 and 5, and those are prime. And 2 and 5, and both of those are prime. So we have 2 times 2 times 5 times 5. And we cancel. And we're left with 3 over 4. And that is the reduced answer for 75 over 100. The same is true with any of these. If I were to do something like, oh gosh, let's do 68. 1, 8, 7, 5. And this is tens, hundreds, thousands, 10,000s. So it's 1875. There's no decimal. You never have a decimal in a fraction like this. 1875 over 10,000. Now you've got to decide, is that reducible? Well, one of the tips that you can determine on whether something is reducible is anything that ends in a 5 or a 0 is 5 is divisible by it. 5 will go into this and 5 goes into this. And this is when it's always convenient to have a calculator handy so that you can save yourself some time. And I'm just going to divide that out and get 375 over 10,000. And 10,000 will divide by 5 and give me 2,000. Now, what do you see here? Ends in 0, ends in 5. That means they're both divisible by 5 again. So we divide that and we get 400. And 375 divided by 5 is 75. Ends in 5, ends in 0. So we can divide this again. And I don't know which is more time consuming, making the factor tree or continuing on with this. So this is going to divide by 5 and give me 3. 80 is going to divide by 5 and give me 16, and that is as far down as it'll go. Nothing goes into both, or 3 and 16 do not go into, nothing goes into both 3 and 16. So, you can do this long drawn out process in order to get here, or, you can use the factor tree. And like I say, I don't know which one is easier, faster, but, they both work. They're both tools that can help you to reduce. And I don't know how other instructors are, but I don't care which tool you use as long as it's the best tool for the job. So anyway, let's continue on with some of these other ones. Number 70 says choose the number that's closest to 10. Well, I have an 8.5 and an 8.05. Alright, so again, when you're trying to figure out, when you're comparing them, they have to have the same place values. This one only goes to 0.5, this one goes to 0.05. So we're going to make two place values on that one so that they both have two decimals to the right of the decimal point. So, which number is bigger? Which number in this case, because we're looking for a number that's closest to 10, so it's got to be the bigger of the two numbers, 50 or 5. Well, 50 is bigger than 10, so this whole thing is closer to 10. And that's it for the problem set 4.1.